All right, we're going to talk about the practical travel salesman problem. So, in our previous lesson, when we first were introducing the travel salesman problem, we had problems where every point went to some. So, like if I had 5 points, for example, every single point went somewhere. Okay, but in this problem, you're going to notice that uh, not every point has um, the graph is not complete. It's not Hamiltonian. It's impossible to visit every town without visiting some of the towns more than once. So, for example, to go from A to E, there isn't a direct route. I'm going to have to go to A, C to E, right? So, um, so I need to figure out a route to get from here to here. And so if you look on the slide just down below, to go from A to E, I have to go, I add 45 plus 25, and that's going to give me 70, right? And if I want to go from A to D, let's see, I could do 45 plus 60, that's 105. I could do 70 plus 30, that's 100. That's probably a better route, right? I can go 45 plus 25 plus 30 is the shortest route. So I need to create pathways through other routes. So I'm going to be visiting some towns more than once. So for example, it's faster to travel from C to D. By the way, let's look at this. To go from C to D, it's faster to go through E, because if I go this way, I've got 30 plus 25. That's going to give me a route, a weight of 55, versus if I go this way, it's a weight of 60, and there's some possible reasons why traveling through E might be better. Okay, so this is called the practical sales route. Okay, so I just drew some examples of what they did here too. So, for example, to go from um, here to here, you would do 30 plus 25. Okay, so that's just an introduction. Okay. Um, you're going to have to watch Pablo Sanchez to do this problem here. He does a good job. So let's do this one here. Example 11. Okay, so the first thing I'm going to do, they want us to complete the graph with edges showing the shortest distances. Okay, so if I draw a line from E to C, let's see. To do this, I have to do 8 plus 11, which is going to be 19. Okay. To go from C to D, I'm going to do 13 plus 11, which is going to give me 24. To go from D to B, what is the fastest route? 13 plus 7 looks like the fastest route. That's a route of weight of 20. And then B to E. 8 plus 7, that's a route of 15. And D to B, let's see, D to B, 13 plus 7, that's going to be a route. Oh, I already did that over here. Oops, I don't need that. I guess that's all of them, right? Okay, so complete the graph with the shortest distances. Okay, I think we're done there. Okay, so now we're going to use the nearest neighbor algorithm, starting with vertex A. So, just so I don't draw all over this thing, I'm going to redraw my grid A, B, C, D, E, and that's 13. This is 19. This is 20. This is 10. 24. 8. 7. 11. E to B. That's 15. I think that's all of them. Okay, so starting with vertex A, so starting here, the shortest route is going to be A to B. Okay, then from here, okay, 10, 20, 15, it looks like the shortest route is going to be 10, so I'm going to go this way. And then from here, 11, oh, I can't go that way because it closes the loop. So 19 and 24. So 19 is the shortest route from there. And then from here to here, oh, I didn't write this down. E to D is 9. So I have to go to D anyways. So that's because that's the last point not visited. So I got to go this way, and then I got to go back home to A now that I've visited all of the points. So what did we just do? We started with AB, which is 7. Then we did BC, which is 10. Then we did CE, which is 19. And then E to D, which is 9. And then D back to A, which is 13. So we add all those together, and we get 58, and this is my upper bound. Okay. All right. So now we're going to use the deleted vertex algorithm with A being deleted. Okay, so if A is deleted, then we've got E, B, C, and D. Okay, this is 9, 24, 20, 19, 15, and 10. Okay, so we've got our drawing. Now we're going to do our min spanning tree. Okay, so our minimum spanning tree, we start off with the smallest edge here, which is 9. So we've got E to D, which is 9. Now the next smallest side is going to be from E to B, which is 15. And then lastly, B to C looks next. And now I've visited all the points. So B to C, which equals 10. So we have our total of 34 for our minimum spanning tree is 34. And now the third, we're going to add the two shortest edges from point A. Okay, so I'm going to redraw point A, put some dotted lines there. Those edges were 7 and 8, and this edge was 13, and this edge was 11. So clearly 7 and 8 are the shortest edges. So I'm going to add those to my 34. So I've got 34 plus 7 plus 8, and that's going to give me 49. And this is our lower boundary. Okay. Okay. So now we've got our lower boundary of 49. And so we know that our minimum spanning tree, or sorry, the minimum weight is between 49, which is the lower boundary, and 58, which is the upper boundary. Okay. Like I said, watch Pablo to do this one here. Okay, example 11. Okay, first off, use the table below to find the values of A, B, and C. Okay, so the value of A goes from A to C. So if I'm going from A to C, here's A, here's C. So the shortest path, okay, 11 plus 9 is 18, and 5 plus 12 is 17. So this is the shortest path. So we know that A is going to be 5 plus 12, which is equal to 17. So I'm going to replace this here with 17. 17. Okay. And now we've got B to E. So if I'm going from B over to E, I could do 11 plus 11, which is 22. Or I could do 10 plus 5 plus 6, which is 21. That's the fastest. That's a smaller weight. So 10 plus 5 plus 6, which is 21. So B to E, B to E. So this is 21. 21. Okay, and then D to E. This was, so from D to E, notice from D to E, the direct route is 21, but this is 6 plus 13, which is 19. This is the more direct route between for these for between D and E. So so this is what we were mentioning earlier. So C is going to be equal to 13 plus 6, which is 19. 19. Okay, so the shortest route is not the direct route. Okay, it's not 21. Okay, so use the nearest neighbor algorithm between town A to find the upper boundary length. So I'm going to use the table here. So we're going to begin with town A. So using the table and beginning with town A, I look at this row here, and beginning with town A, I see the smallest weight is 5. So I'm going to start off with A to F, which equals 5. So now and everything on this I'm going to cross out, and I'm going to cross off everything here too, because I'm not going back to A until I'm done. So now from F, I'm going to look at row F, and the smallest one available there is to G. So now I'm going to go from F to G, and that value is 5. Okay, so now I can cross out this column, and I'm going to go to row G, and the smallest one in row G looks like 6. So GE is equal to 6, and then I'm going to cross out this column here, and so I'm at E now. So I'm going to look at row E, and I've got 21, 16, and 19. So 16 is the smallest one in row E. So I'm going from E and to C, and that's a weight of 16. And so now I'm going to look at row C, and I've got 9, 0, and 7. So I'm going to say C to D is equal to 7. I guess I should have crossed off. Okay, and we are left with, I think we've gone to every point, A, F, G, E, C, D. So we just need to go from D to B. So we're going to go from D to B, which is equal to 16. And now we've hit all the points, so now we need to go from B back to A, and from B to A is 11. So now I've done all the points, add those together, and we have a total of 66. So our upper bound equals 66. Okay? And so if the driver were to follow this route, which towns would he pass through more than once? So the actual route is A, F, G, E, G, C, D, C, B, A, because of the shortest distance thing happening here. And so what we're going to actually be doing is we're going to be visiting G twice, and we're going to visit C twice. So towns G and C are passed through twice. Okay, so next. See how far we go before the bell rings. Okay, so complete the graph. Okay, so what's the distance from here to here? It's going to be 13 plus 9, which is 22. The distance from here to here is 6 plus 9, which is 15. The distance from here to here is 10 plus 8, which is 18. From P to S is 8 plus 22. No, that's not the smallest, shortest way. 17 plus 9, which is is that the shortest way? I wrote 25. Hmm. Um. Oh, 10 plus 6 plus 9. It's going to be 25. So P to S equals 10 plus 6 plus 9, which is 25. Okay, and then is that everything? I think that's all of them. Okay, so graph is completed. Okay, use the nearest neighbor algorithm starting with vertex P. Find the upper bound. Okay, so starting with P, the shortest one, 25, 8, 17, 10. Okay, so clearly 8 is the shortest path right there. So got P to T, which is 8. And then I'm going to go, let's see, 13 looks like the shortest path from T. So we go T to R, which is 13. And then the shortest path looks like 6. So I'm going to go this way. So we go R to Q, which is 6. And then from Q, 15, 18. Oh, I can't take 10 because that takes me back to P. So I'm going to go this way here to S. So I go Q to S, which is a route of 15. And then from here, let's see. Oh, we've done all the points now. So now we go back to P. And so going back to P is 25. So S to P equals 25. So our total equals 67. So our upper bound is 67. Okay. Use deleted vertex algorithm with P deleted to find the lower bound. Okay, so I'm just going to redraw this. T, S, Q, R. That's 18, 6, 9. This is 15. This is 13. This is 22. Okay. Here is P. I just drew it dotted, and that's 10 and 8. Okay. So looking at P being removed, we've drawn our picture. Next, we're going to find our min span tree. So the first thing I do is I look for the smallest edge here, which is 6. So I know that QR equals 6. Then we need to go to another point. So that's 15, that's 18, that's 13, that's 9. So we're going to do SR. Are we going to do SR? Yeah, that's 9. Okay, and then the next we need to get to T. So the shortest route to T is going to be 13. So we're going to do RT, which is 13. So we add those all together, and we get 28. So our minimum spanning tree total is 28. So now the third thing is we're going to add 2 deleted vertices from P. Okay, so the 2 we're going to add are 8 and 10. So we've got our 28 plus 8 plus 10, which adds up to 46, and this is our lower bound. Okay. Okay, so we've got our upper bound, we've got our lower bound. So it says solve this by inspection, and if we inspected correctly, we end up with going from P to Q to R to S, back to R to T and to P, and that adds up to 55. And this can be verified that this works because my lower bound was 46, and 55 is between the lower bound and the upper bound. Okay. The last two questions I'll have to do in a video, a second video, because we're about to run out of time before the bell rings. Or actually, I'll just put this up here. You can check your work. Okay, and then the last question. The three cities that go to A are C, E, and F. I only drew the ones that had values. Okay. And here's the last page. Alrighty, that is it for this chapter.